All right, so this is part 3 of the video. This is the last part of this lesson. Next I have a little bit of a graphic organizer. Um, just giving you the definition, the key facts of the zero solutions roots of a quadratic function. Okay, so this is just a very important concept for you to know. This is basically what the whole unit's going to be about, is different ways we can solve to identify those zeros or the roots, whatever you like to call it. So just to put in your notes, you should draw this out on a piece of paper in your notes. Write the definition. So the definition of this is where the x values are the points that hit the y-axis. Some key facts is that the y value of the solution is always 0. All right, and I have an example for you here. This is an image of a parabola pointing to where your roots are. So your solutions are -8, 0 and -4, 0. So that -8 and -4 are your solutions. So it's only the x values that are the solution. So your solutions are x equals -8 and x equals to let me rewrite this better, and x equals to -4. Those are your solutions. And notice your y values are always 0. So x equals to -8 and x equals to -4. It hits the x-axis in two places, right here and right here. Okay. Next, a non-example of a solution would be the vertex point. So the vertex point, your maximum and minimum point, is not a solution. It's just the vertex. It's just your maximum and minimum value. So it's different. These points have a different meaning than the maximum and minimum point. So this is what I want you to see from this little organizer. Okay, next, I have another just model example for you guys. So I want you to solve 3x squared minus 8x plus 15 equals 0 graphically. So why is the equation equal to 0? So what this is asking you to identify is, if you were thinking it hopefully, is the solutions. So it's equal to 0 because they want to know what are the x values when y equals to 0. Okay, so they're asking you for the solutions. So they're asking you to identify the solutions, the roots, the zeros, whatever you like to call them, of your parabola. All right, so using your graphing calculator or Desmos, graph this function. So you're just going to put in 3x squared minus 18x plus 15. And I have a picture of what that looks like on Desmos, okay? So you go to Desmos, type it in, or I have the picture here for you. Okay, and what are the solutions? So if you look here, so of course, we're looking for where the parabola hits the x-axis. So it hits right here. This is one solution, and this is another solution. Okay, so what is this point? So it's right in between 0 and 2. So this point is 1, 0. And this point is right in between 4 and 6. So that has to be 5, 0. So your solutions are just the x values. So your solutions are going to be x equals to 1 and x equals to 5. Okay. Now, how can we verify them algebraically? So anytime you're asked to verify algebraically, they just want you to substitute. So first we're going to substitute x equals 1 into the equation. So instead of putting x, I'm going to replace everything with 1. Oops. Okay. So I'm replacing x with 1 plus 15. And this should equal to 0. So first you evaluate the exponents. So 1 squared is 1 minus 18 times 1 is 18, plus 15 equals 0. And this becomes 3 minus 18 plus 15 equals 0, which we get 0 equals to 0. So it works out. Now let's try x equals to 5. So again, you're going to substitute 5 for x. You can put this directly into the calculator as is, or you can go step by step using order of operations. 5 squared is 25 minus 18 times 5, which is 90, plus 15. Then 3 times 25 is 75, minus 90 plus 15. And that happens to equal to 0. And that's how we can verify the solutions. So you're going to try this on your own, okay? This is going to be part of your practice. I want you to graph this on Desmos or your calculator and identify where those solutions are, okay? And then I'll see you next week for lesson 5. Have a great day.